In this video, we're going to start work on the functions in Python. So first of all, what do you guys see from this two pictures? Um, so you will notice that they are actually like for this one, it's like all of the squares, right? And you can find the items, and it's kind of like repeated itself. And how do we make this happening? We can use function, the concept of functions. So the objectives of this class is understanding why, when, and how to use functions. Write your own functions, accept values from your functions through parameters, and learn how to return information after the function is done. And work with the global variables and the constants, and create computer components that plays a strategy game. Um, so the reason we used functions normally is because the functions is a normally we want to design functions as a atomic tasks. So when we have a big problems, we're going to break it down into smaller tasks, and then go keep on breaking that big tasks into smaller problems. Eventually, you're going to have a small set of instructions that only accomplish a very simple um, task, and and then you can reversely combine those tasks to accomplish a bigger tasks. So the whole thing is actually follow the philosophy divide and conquer. Um, so some people probably read a book is how to uh, take an elephant out of a house, out of a room. The philosophy is actually divide and conquer. So when an elephant is in your room, it's too big. You can't just take it out. So you have to divide and conquer. Take it small chunk and take it out, right? Same thing. We're gonna use that, but eventually you're gonna use the functions, and for each of the small tasks, it's gonna be a function, and then you assemble the functions together. It's gonna make the whole task done. So we try to avoid writing the redundant program code, so we can has a better use of those resources, and enhance the readability and the maintainability. So in the future, when you are reading your own code, it's easier to understand. It's easy to follow the flow of the data or the logics. Um, and it's a lot easier to test and correct errors, because you all you need to do is focus on a function, and then you just make it correct, and then each time you focus on a smaller problems instead of like tons of errors and bugs have it's harder to debug. um, so that's the why we need to write functions. um, some people call it methods in the object-oriented programming. It's no much difference. Functions and methods. Methods is just inside and class, inside a class, and then you have a bunch of functions. That function normally associated with a class. We call those are methods. While functions normally has nothing associated with a class. It's a lot of times is a procedure programming. So that's the only difference. But for the concept of itself, the function itself, there's no much difference. You're going to have a return value, then function name, and then a bunch of parameters. And inside the body of the function, you're going to do all those calculation or operations. So let's take a look. Let's simply just break it down of a tic-tac-toe game, and later we can actually implement this one. We first display the game instruction, and then we are going to determine who goes first and create an empty tic-tac board, and then we can display the board, and then this one we can define a function to avoid the repeated game, because later we're going to display board right here, and later we display the board again. So we can define a function, so that will make it simple, and we don't have to write the same code twice. And then while nobody is won and it's not tied yet, so it is a human's turn. If it is human's turn, then get human's move, update the board with the move, otherwise calculate the computer's move and update the board with move. So you notice that I actually do the update the board with move twice, so that's ideal to define a function so we don't have to repeat the same code, same set of instructions twice, right? So, and then we switch turns, and then we congratulate the winner or declare a tie, right? So here's a basic definition of a function. For example, we want to define instructions at the beginning. For this part, display the game instructions to improve the readability. What you can do is define instructions. So we have to have def. We have to have a def is a reserved keywords, and then the function's name, and then colon indicate that's actually a function. And here is the display game instruction for us to read, and then print welcome to the world of greatest game. And then this function makes the program easier to read and write and maintain. And the function definition is simple, right? The header part is actually the definition. So you are specifying the function's name, and then in this case we don't take any parameters. So that's then sometimes we want to do some documenting a function. So we can add a doc string, the string that documents a function. To do that, you can do a triple quote string at right below the functions, and it must be the first line of your function. Normally it's not required, but it's normally is a good idea. Pop-ups as interactive documents in IDE, so that will be good. When you call a function, you can simply just write the function's name and then put parentheses. If you have parameters, you're going to put parameters inside the parentheses. Tell the computer to execute the predefined functions. Okay. Abstraction. When we are dealing with the object-oriented programming, then sometimes we need to understand the concept of abstraction. It is actually a mechanism to let you think about the bigger picture without worrying about the details. Abstraction a lot of times is just to find the common features of a bunch of classes. For example, when we have bird as a parent class, I want you to find what's the common part of a chicken, a peacock, a goose, a duck. What's the common part? Then you can list those common parts and then put that into a bird class. This is kind of like abstraction. So functions also has this kind of concept. You are going to look at the bigger pictures, and you don't have to worry about the details. Encapsulation means you are going to put everything separately by hiding the details. Encapsulation, it is, for example, when you have the function, everything that has been enclosed inside the function body, that's the encapsulation. The parameters and the return values actually doing the information exchange. The whole function itself, it's acting like a black box. When you call the function, you just don't need to know what's the details inside. It's like you're taking a medicine pill. It's encapsulate all kinds of medicine inside. You don't want to know. You don't need to know. All you need to do is, I take this medicine. It's going to kill, for example, virus. Then you just eat it, right? So this is you don't have to understand the details. So that's called encapsulation, and you normally will receive, in some cases you need to receive some information. All you need to do is just take some parameters, take some values from the parameters. What it does is, suppose I want to print some message. However, this message, I expect the user actually, whoever is calling this display function, actually pass the message to this function body. So the parameters are actually a bunch of variable names inside the parentheses that will be assign a value when people are calling those functions. So people have to give the values to those variables. Well, the arguments are actually the value that passes to the parameter. So parameters are variables. When you define the function, you're going to have parameters. Well, the arguments is when people actually call it, they give the value to those parameters. So that's the difference between parameter and arguments. Parameter actually must get values, otherwise it's going to give you an error, because that's how it works. Just like plumbing, right? When you have the pipes, you expect the pipe is connected with water, otherwise it won't work. So the parameters is like the valves, and then the arguments is like the water hose that connects to the valve. So wonder if and how you can pass parameters to your program. Do you wonder if and how you can pass a parameter to your program? Use the SYS module. You can use that. You can use SYS sys module. Sometimes you don't need to return value, but a lot of times you do need the return information after the calculation. For example, give me 5, or doing some calculation. Let's say calculate Fahrenheit to Celsius. If you ask people input some values, then you want to return that value. So in this case, is just give me 5. You are going to return 5 back to this whoever is calling. So that will return a 5. A return value basically is a value returned by the function. When people call the function, they are expecting to receive a results. So the return is actually the statement, return the value. Return will actually terminates the function call, function instructions. Normally is if there is some code behind, they want to be executed, because the return is actually terminated the method, the function. Okay. And to call that, it's very simple. You can directly assign the function to a new variable. And this variable is going to have a value number 5, because this 5 is actually returned. And so the whole statement is replaced by number 5, and a 5 is assigned to number. Okay. Receiving and returning values. Sometimes in a function, you have your receiving values from parameters. So like you receive questions, okay, and then you return responses. So suppose your questions received it. So this will actually turn the questions to a lower cases, and will becomes your responses, and then you return. Just in this question, it's just a yes or no, right? Yes or no. So receive in this case is receive one value and return another value. So the positional parameter and the positional versus keyword arguments. So in this example, you're gonna see the birthday is the name and age. Birthday has the two parameters. One is name, the other one is age. Then the function is defined as print happy birthday, and the name of this name, and then you are the age is given right here. So when you call the function birthday, it's gonna give you the name Jackson. You are 1 year old, right? You are 1, and then birthday number 1 and Jackson. So in that case, it will actually becomes the position will becomes matters, right? So this will give the name what becomes 1 and Jackson what becomes age. So the order matters. So if this is name, you have to put the names first, and if this is the age, then you have to put the age later. However, if you say, well, if I specifically tells the keyword arguments, if I tells age is 1, name is Jackson, then that didn't matter anymore, because you are explicitly tell this function that my age as a keyword parameter, it's gonna be 1, and the name will be Jackson. So in that case, it won't matter. The keyword arguments actually pass the correct arguments to the parameters. So the biggest benefits is you don't have to you make it clear. You made it clear. However, you type more words, that's for sure. But all the benefits are not free at all. So you actually spend more time. However, you make it clear. So another one is you can use the default parameter. Suppose I specify a default parameter. So like I define a birthday, I specify the default value will be Jackson, age will be 1. So sometimes if you don't define something, like if you just simply call name is Mac and you don't specify age, then this will change the age, will keep the age as still at 1 and just update the name to Mike. So this is just one example. And then positional or keyword, or none or. So once you see the keyword argument, all the remaining arguments is in the same function, must be the keyword. So for example, if you have a function defined as name equals Mike, and this one is you don't specify, then it's going to give you a syntax error, because either it's none of them use the keyword, or all of them has to use keyword. So it's actually none or. So this is actually a correct way to call. You either do not use keyword at all, or for every single parameter you have to use a keyword. So that's the none or. Once you assign a default value to a parameter, you will have to assign the default value to all the parameters. So when you define that, if you define one parameter as default, then you have to sign all the parameter listed after it. Then for the ones before it, you don't have to. You only put the default values at very end. So, but this is okay. Syntaxly, it's okay, but it can confuse people. So it's either I will suggest you to do the same philosophy, long or. If you don't put default values, then don't put it for everyone. Then if you put one, then better to put it for everyone. Next concept is called the global versus local scope. The scope basically means the different areas in the program that a variable is visible, or sometimes you're going to see it's actually logic blocks, different areas, a program that are separated from each other. So a lot of times you may see column or curly brackets. Those will clearly define the scope. So every function has its own scope. The functions cannot directly access each other's variable because the scope of the variables are local. They're local. Well, only the global variables can be accessed by every single parameters. A lot of times for functions, you have to use the parameter or return value to exchange information. So keep that in mind. For example, this is a function, and this is the local name. So what does this function mean? This is function 1. It's going to have the logic block, this line. It's inside the scope of the function. So the func1 will have the local name, and you can print local name and the global name. The global name will be whatever this name is, will be visible everywhere. So this is just the definition. This is actually the actually execution. So we first define a global name right here, and then we have the func1. So func1 will have a local name, and however the global name is the same level as the function name, function1. So they will be able to access. They will be becomes a global. They have a bigger scope. So this one, the area, the scope of a global name is actually starting from this line to the end of this file. So starting from this line to the end of the file. Any lines before that, it will not be able to see it. However, those definition is actually technically they are not the executable lines command yet. It's just to specify a rules, a bunch of instructions. So only when you call it, it becomes a actual function calls. So you can actually move those anywhere in this file as long as it's before func1. It will be, otherwise it won't recognize. So this has to be, func1 has to be before it's accessed. That's just the definition, right? Its definition is not actual execution. The actual execution will be happening when it's being called. Func2 is the same thing. You only have local name number 2. And here, if you want to access local name 1, it won't happen because local name 1 the scope of local name 1 is from its definition, the line of this definition to the end of this function. Same thing, local 2 is starting from the definition to the end of this function. Once you are out of this function, you are not be able to see the local name number 2 anymore because it will be eliminated from the memory. Shadowing and changing global variables from inside a function. So for example, I have a global value. So I have a value 1, and then I want to have a full access of value 1. Like I want to update it, right? So in that case, I have to put a global right here to indicate this is actually a global variable instead of the ones, otherwise it may treat it as a local variable. So once you put a global inside the demo function, you are basically tell the function, hey, the value 1 is actually a global variable. And then you can start to doing all the access. You can read the value, you can update, you can change, right? Change the value of value 1. And for value 2, you see value 2 is actually a local variable. A new variable with the same name. It's actually just a shadowing. So value 1, 2, 3, they are actually global variables. So you are inside the scope, and it's gonna give you those values. Okay. And you will see if you don't put the global, the values, they are different. They're different. This is just one example, tells you the difference. Understanding when to use the global variables and the constant. A lot of times we use the global variables can lead confusion because it's valid the encapsulation, right? It's not encapsulate all the related information inside a function. It's kind of break that rule a little bit. So you try to limit to use the global variables, try to use some local variables to do that. However, sometimes you will have to use a global constant. For example, some mathematic constant values. Let's say pi. Pi is one of the constant global constant. You will have to use it like everywhere. Then the global variable is treated as a constant. So use a global constant can make the program cleaner. Otherwise, you're going to define a lot of local variables with the same value. So, and then how do we further implement the tic-tac pseudocode? So this is actually the blocks that we just mentioned. Then we're going to actually make this happening. So the first of all, you're going to prepare the tic-tac-toe data. You're going to make the whole like chessboard as totally 9 places, and X will be X, and then O will be O. So X will be one player, and O will be another player, and then you can start to doing all those. You can do display instruction, ask yes, no, ask a member, and then pieces, and then you can do all those rest. So another related function is called recursion. So sometimes when we are facing some very, very complex problems, we don't have a solution, we can use a recursion function to solve it. That will make some difficulty things easier. However, it also has the cost. It also has a cost for the recursion because, as I mentioned, everything it's not free. You are actually use something to exchange it, right? Here you simplified the problem. However, you are spending a lot more memory and computing resources. So this is the recursion. So what the recursion says is how do you describe this shape, right? You basically has a big triangle, and then you keep on doing those small triangles, right, until you fill those spaces inside this big triangle. So this will make the shape with a few simple rules. So you first with an equilateral triangle, and cut a triangle whole out of all the current triangles, right? And you first have a triangle, and then you cut a whole of the current triangles, and then you repeat the number 2. You keep on cutting another triangle. So you make another hole of the triangle, and then you make another hole of triangle, and then because this is another space, then you keep on cutting this one, and then keep on cutting this one. You can repeat number 2 forever. And this is a kind of like a recursive definition. This shape is created through the use of the recursion. Recursion functions make use of their own previous values in their definitions. Recursion works by breaking down a large problem into smaller problems. This is just one example. Otherwise, for this problem, it's harder to determine how many exactly triangles we're going to have. But with this algorithm, we don't need to worry about it. We don't need to do the definition. We just keep on calling the function itself. So what's the basic definition of recursion? So for recursion functions, you normally has 2 steps. One is the basis step. That's actually the way out. You need an exit to jump out of the recursion. Otherwise, the recursion itself will becomes an infinity loop. It will keep on calling itself, right? So in this case, recursion is actually the way out is when n becomes 3, you're going to, when n is 0, the whole function is going to return number 3. And the recursive step is when f of n plus 1 equals 2 times f of n plus 3. So then you can define this one as actually you can derive from here. You can find what's f of 1. F of 1 is actually equals to 2 times f of 0 plus 3. So 2 of f of 0, that will be 3. 2 times 3, that will be 6. 6 plus 3, that will be 9. F of 2 will be 2 times f of 1 plus 3. 2 times f of 2 times 9 will be 18 plus 3. That will be 21, right? So this is how do you do. And for example, another example is a factorial function. Factorial function can be defined as x factorial equals to all the numbers from 1 to x multiplied together. So you have 5 factorial is actually equals to 5 times 4 times 3 times 2 times 1. And here we can actually define f of n equals to factorial recursively. How do we do it? We can simply define f of 1 equals 1, and then we can establish this one, f of n equals n times f of n minus 1. Again, this is in one of our classes. It's called discrete mathematics. But you don't have to. If you have difficulty understanding for right now, you don't have to understand right now. We can do this later. So the function actually factorial pseudocode can actually doing this. This function takes a number. If the number is 1, then we are at the basis step. Then we are going to return 1. Otherwise, we need to recursionally call the number times the next step. So that will leave us like this. Define a factorial n. If the number equals to 1, then we're going to return 1. Else return n, the number factorial, the number minus 1. So that will be the definition. Right now it's just blank. So you can actually test that, and then we can also define the Fibonacci numbers, basically following the same thing. So f of 0 equals to 0, f of 1 equals to 1. So for Fibonacci function, those two are the basis. There are 2 bases. So basically means there are 2 exits. So if n equals to 0, you have to return 0. If n equals to 1, you have to return 1. And then you can, otherwise you can use this formula. It basically is f of n equals to f of n minus 1 plus f of n minus 2. So that will be it. Here's the algorithm. So you have number equals to 0, you return 0. If number is 1, you return 1. Else, return Fibonacci itself, and n minus 1 plus Fibonacci itself, n minus 2. So this will be our recursive definition. But again, this recursion part is a little bit harder to understand. For right now, if you kind of get lost a little bit, don't worry about it. We are not going to intensively use them right now. It's only when you are dealing very, very tricky or hard problems that temporarily has no solution, then you can use the recursions. But most of the time, our problems are predefined. You don't have to use the recursion functions to solve those problems. Okay, finally, as a summary, what we learned in this class is we use the keyword def to define a function. For the function header part, you're going to have one line to specify what's the function's name and what's the parameters. And for the parameters, we may have some default values. We may have some keywords, but for all of them, it's basically for parameters. They're basically a bunch of variables that will be predefined and used in the body of the function. The arguments, well, is actually the values that pass to the function by the corner of the function. So the arguments eventually will be assigned to the parameter, and the parameter will actually take place inside the body and do all the calculation. Well, keyword arguments actually are the arguments passed to the specific parameter of the function by using the parameter's name. So this becomes a keyword. However, it's happening in the caller. When you call the function, you are going to use the keyword to explicitly tell the function, hey, this is the parameter, and the value is this, and the parameter is, and so it becomes a pair, parameter and the value, parameter and value. And once you're using the keyword, you have to follow one rule, like or none. If you use keyword, then all the parameters you're going to use has to be keyword. Otherwise, you don't use any of the keyword. The default value definition is the same thing. Default value, when you define the parameter, you are going to use give some parameter some predefined or default value. Same rules. If you want to use default parameters, you're going to define all of them, all the parameters. You're going to give a default value. Otherwise, you don't use it at all. The return value actually will be the value that is returned by the function after it goes through all the calculation. Well, abstraction is actually a mechanism. Let's let you think about the big picture without worry about the details. So when you are calling a function, you don't need to worry about the details. All you need to know is just what does this function do. So you focus on that part, and then you don't need to worry about how this function, how this details has been laid out. And the encapsulation is about the same. So basically means you are put all the related steps or instructions or data in one function, so it's enclosed, it's separate from other places, other functions or other part of the file. Variables and parameters created in a function normally will becomes a local variables. The scope of those local variable will just inside the body of the function. Well, there are some other variables that are declared inside the file of the Python that will be called global variables. Global variables normally will be accessed by everywhere inside the file. However, you have to declare some variables as global. so you can access it inside a function. So those are basically a summary of this lecture. That's all.